Hello again. I'm Dan Fleisch, and this is the introduction to the fifth and final chapter of A Student's Guide to the Schrödinger Equation. If you've read the earlier chapters, especially Chapter 4, you know that the general characteristics of quantum wave functions can be discerned just through a consideration of the form of the Schrödinger equation. But what if you want to predict the possible outcomes and the probability of each of those outcomes of a measurement of a quantum observable, such as the position, momentum, or energy of a particle? To make such predictions, you must know the potential energy in the region of interest. So in this chapter, you can learn about the wave function solutions to the Schrödinger equation for three specific potentials: the infinite rectangular well in section 5.1, the finite rectangular well in section 5.2, and the quantum harmonic oscillator in section 5.3. Why did I choose those three particular potentials? One reason is that I think each one provides an instructive application of several of the concepts and mathematical techniques described in previous chapters, including the use of the inner product to find the components of a function, finding the eigenfunctions and eigenvalues of an operator and using the result to predict the probability of measurement outcomes, and using the Fourier transform to move between position and momentum space. But these examples also introduce or extend several concepts and techniques that have not been discussed in detail in previous chapters, but that you're very likely to encounter in your study of quantum mechanics. Those include the application of boundary conditions, the solution of transcendental equations using graphical techniques, parity considerations, and the use of ladder operators. Although the three examples in this chapter are all one-dimensional and consider potential functions v of x that vary over space but are constant in time, they all provide a basis for solving more complex problems. So the techniques and wave function solutions you'll see in this chapter are useful beyond these three configurations. They can be combined and modified to help you attack a variety of real-world problems. And, speaking of problems, I'd be remiss if I didn't mention the problems at the end of the chapter. Be sure to work through those, using the online hints and solutions to get help or just to check your work. Thanks again. Good luck.